Well, welcome to this small video on some math that we need to recall from previous math classes. Let's talk about numbers. You see down here at the bottom, the smallest set of numbers are called natural numbers, and they include 1, 2, 3, 4, and going off to the right forever. Sometimes you'll hear people call these the counting numbers. Moving up in size, we have the whole numbers. Whole numbers have all of the natural numbers plus one more, and that's the zero. Moving up from there, we have the integers. Integers start going off left forever. -2, -1, 0, and then 1, 2, 3, 4 on to the right forever. So you see you've got all the whole numbers, but now we've included the negative numbers. The rational numbers. Rational numbers mean all fractions. Everything that's writable as a form of P over Q. P and Q can be anything you like, just not the bottom being 0. And even bigger yet, we have the collection of real numbers. Real numbers have all of the previous numbers, but they have something more. Because there are some numbers like square root 2, pi, e, that are not writable as a fraction. So, all of these numbers you should be familiar with. We also have our number line. So the number line is called R1. R1 because they are real numbers. Here's 0. Going to the right, we've got all the positive numbers. It goes off to the right forever, and right forever is plus infinity. If I go to the left, I've got all the negative numbers, and if I go to the left forever, that's minus infinity. Now, if I take two of these number lines and I crisscross them, what I get is called the plane. I have an x and a y axis. This is R2. You could think of it the 2 because we've got two axes here. X-axis is on the bottom here. The vertical one is the y. They are linked up right there at the 0, and that's called the origin. Now to locate a point here, then I simply move in the x direction, whether I go right or left, and then I go a y direction, which is up and down. This little square is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. So you can see anything that lives in quadrant 1 would have both of these numbers positive. And if I'm way over here in quadrant 3, then to get there, I'd have to go left, which is negative, and down, which is negative. The origin here is 0, 0. So, no reason to stop there. You could crisscross three axes together. You have a x-axis, a y-axis, and a z-axis. I mean, video games wouldn't be much fun if they were all just flat and two-dimensional. So, 3D. Up is positive, down here is negative. Coming out is positive x, back is minus x. Y is positive this way, negative that way. And to locate a point in three-dimensional space, you would need a x, a y, and a z. Let's talk about some number operations that maybe you forgot. 5 minus 3 is 2. Okay, because we're at 5, we go down by 3 units on the number line. We are at 2. If I had 5 minus a minus 3, so I've got two minuses here, and when that happens, that converts to a plus. 5 plus 3 then is 8. If I multiply a positive number times a negative number, the result is negative. If, though, I've got two negatives multiplied together, that turns into a positive. If I have a fraction, as long as the top or the bottom is negative, the answer is going to be negative. If the top is minus and the bottom is also minus, then the answer has to be a plus. Just like here with the multiplication of two negatives is a plus. Sometimes there is a confusion. What do you do with the minus? Well, the minus can go in the top, the minus can go in the bottom, or the minus can go in front of the whole fraction. All three of these are exactly the same number, and that number is minus 2. So again, put the negative in the top, the bottom, or out in front, whichever the situation calls for. Let's talk more about fractions. 0 on the top divided by 3, well, that's just 0. So anytime 0's on the top and something that's not 0 is on the bottom, the answer is just 0. If you have a fraction where the bottom part, the denominator, is 0, we say the whole fraction is undefined. And even worse than undefined, if we have 0 over 0, this is undefined and it's also indeterminate, which means you must do more work to figure out, well, what exactly is going on. Let's see, multiplying. All right, what if we would like to multiply fractions? Well, multiplying fractions is easy. You just multiply straight across. So 1/2 times 1/3 is 1. On the bottom, 2 times 3 is 6. When you're multiplying, if you can cross reduce or cross cancel, do so, because it makes the numbers smaller. So for example, 5 goes into 10 2 times. 5 goes into 15 3 times. And so now I've got 1 times 3 is 3. 2 times 2 is 2. And I get 3/4. If we need to add two fractions and they have different denominators, I can't just add them straight away. I have to make them have the same denominator before I can combine them. So I've got 1/5 and I multiply that by a form of 1, which is 2 over 2. And so that would give me 2 over 10. If I take 1/2 and I multiply that by another form of 1, which is 5 over 5, I get 5 over 10. Now that I do have the same denominator, I can add the two fractions. The common denominator stays the same, and I simply add together the top part. Now, how do you find this common denominator when it's more complicated? For example, I want to find the common denominator for 10, 9, and 5. Okay, what do I do? I prime factor each of my numbers. So 10 is 5 times 2. 9 is 3 times 3, and 5 is 5 times 1. Once all of your numbers are prime factored, I start looking. Okay, there's the 1. The next prime number in all of this is 2, but I only see one of them. Okay. I go to my next prime number, which is 3. Oh, I see there are 2 of them. All right, so I need 2 of them. I go to my next prime number, which is 5. Well, there's only one 5 appearing in here. And so the common denominator is 1 times 2, 3 times 3 times 5. So 2 times 9 times 5. And so the common denominator would be 90. So again, prime factor each of the numbers. Look at your factors. For each prime number, pick the most of them that's there in the problem. All right, what about if we need to divide something? 2/3 divided by 1/8. Well, the way you handle two fractions stacked up like this, you take the top fraction and you multiply it by the bottom fraction flipped over. Again, top stays the same, bottom fraction gets flipped over. And so now I'm doing an easy thing, which is multiplication. 2 times 8 is 16. 3 times 1 is 3. There was no cross canceling to be done, and so we leave the answer as 16/3. When we're doing some algebra, if I have something like 3x over 8, if you want to pull the fraction part away and write the number in the front, that's doable. Nothing is wrong with that. They might say, well, why does that work? How do you know that? Well, if I've got 3x over 8, I could really write this as 3 times x over 8 times 1. And then I just write this as 3 over 8 times x over 1. But anything over 1 is just itself. So if it's more convenient to pull the number away from the variable, do that. If I've got a negative in front of something, if it's beneficial to the problem, then pull the minus away as a -1. Let's talk a little bit about radicals. So if I've got a square root of 4, that's 2, because 2 squared is 4. If I've got the square root of -4, there are no real numbers that when multiplied together would give me -4, because they have to be the same number. So what happens? Well, I can split off the -1, split the radical. This square root of 4 is 2. And then we agree to call this thing, this square root of -1, it's not a real number. It's a complex number, and we call it I. So if I had the square root of -16, that would be 4i. Sometimes we're going to need to simplify a radical, so square root of 50. I'm thinking, how can I split this number into some square roots I might know? Well, I'm thinking 25 times 2. So that would be square root of 25 times square root 2, and I would get 5 square root 2. Now the really interesting thing is this I business with complex numbers only happens with even roots. Cube root of 8 is 2 because 2 times 2 times 2 is 8. Cube root of 0, that's just 0. But the cube root of negative 8, there's no I in there. The answer is simply negative 2. So negative 2 times negative 2 times negative 2 is minus 8. Alright, so hopefully this brief video, boring though it may be, hopefully it helps you remember a few things that perhaps that you forgot. Watch it as many times as you need so that you kind of figure out what's going on.